Hey there, James again here with Penner Trailer Sales. This time we're outside and I'm going to demonstrate and go through the proper procedures for hooking up a trailer to a truck. This is a bumper pull application. Gooseneck is largely the same. It's just that the ball is in a different location. It's in the bed as opposed to back at the bumper. Later on, we'll look at proper loading procedures for loading a piece of equipment as well. But for now, we'll focus on getting this trailer connected to the truck. As you can see, we already have the ball positioned under the coupler. So for proper terminologies, this is the coupler. This is the adjustable channel for the coupler. This is the ball mount, or this is the hitch, and then it is slid in the receiver. Technical terms there, but we'll work on getting this coupler down on the ball. It's good as you're jacking this down to not get distracted, but to go ahead and run the jack all the way up so you don't forget about it later on. This is a drop leg jack. It's called a drop leg because you can drop the foot and lock it in a pin. So when you're done, you want to make sure you have the drop leg all the way retracted and the pin locked so it doesn't give you any trouble later on. We've got the coupler down over the ball to make sure that the latch is latched. This is on the technical side, some couplers require a pin to be latched, even though they'll latch, but Department of Transportation requires a pin to be in them to be considered fully latched. This particular one, and actually, if I'm not mistaken, this is the only coupler on the market that doesn't require a pin, and it says right on it, no safety pin required. It does have provision for one here, but I usually don't bother because it's not required on this, but it sure doesn't hurt anything if you'd like. Next, we'll move on to the safety chains. It's good to cross the safety chains and not just hook them up in line so that if the coupler did come uncoupled, it wouldn't just drop in between the chains, but rather they can be crossed and theoretically catch the coupler if possible. So we'll take this one from this side and put it over here, and conversely, bring this one over here. You'll notice my chains are twisted, and you want to watch and make sure that the chain isn't too long and dragging. This isn't touching, but if you were to go down the road, that chain would drag from time to time and wear through, and you don't want that to happen. So the proper thing to do is twist it a bit until you've got proper clearance or so, about like so. Next thing we'll do is the breakaway. This is a breakaway switch. It's connected to a breakaway switch. It's actually just a plug in here. When I pull this out, the switch closes, and there's an onboard battery that energizes the brakes and applies the brakes in the event that the trailer leaves the vehicle. That way the trailer will stop and you won't have a runaway trailer. This has a latch, a clasp on the end. Some cables only have a loop, and those you have to pull it out and thread it through the tow vehicle and through itself and then plug it back in. If yours does not have this and you need to pull it out to loop it through, you want to do that before you plug in your trailer plug. Reason for that is because this is going to energize the brake system, and so there's a couple terminals on here that will be energized consequently from that onboard battery, and is some risk of backfeed to the vehicle with that in that case. So just proper best practice to take care of this before you plug the trailer in. But in this case, we have the clasp, so that's connected to the vehicle. It's not proper to hook it to the chain. A lot of people will because it's easier, but legally, by the book, the law enforcement, they're going to want to see it connected right to the vehicle. And finally, got the trailer plug. Want to make sure it's routed to where it's not going to be pinched or drag, firmly seated like that. Of course, then it'd be best to walk around the vehicle, make sure all the lights are functioning properly. But there you have it. That's a proper way to hook up a trailer to a truck and be able to answer any questions. If a law enforcement officer was checking it out, that's exactly what they want to see. So now that we have the trailer properly connected to the truck, now we're going to talk a little bit about, and I'll demonstrate loading, in this case, a skid steer onto this trailer. Now, with a hitch, they talk about tow rating and tongue rating or tongue weight. Generally, if a hitch is rated to tow 10,000 pounds, that means it can tow, it can drag, it can pull 10,000 pounds along. And 10% of that is usually what the tongue rating is. So there can be 1,000 pounds then in that case. If it's 10,000 pounds towing, it would be 1,000 pounds of tongue weight that hitch is rated to carry. That's generally the rule of thumb in any hitch, regardless of the rating, the tow rating and the tongue rating, 10% of the tow rating. So generally speaking, you would want a weight distribution of the weight on the trailer onto the tongue of about 10% of the weight that's on the trailer on the tongue, provided you don't exceed the tongue weight. If you don't have enough weight on the tongue, you'll have what we've commonly seen. There's plenty of YouTube videos out there and demonstrations of what happens when you don't have enough tongue weight. There's too much weight back on the trailer. You get a fishtail and it can end you up in the ditch, and it could go very badly. So first things first, I've got the ramps here. I've already got one down. We'll go ahead and put the other ramp down. I like to go ahead and take my flat bar off. That way I'm not the guy that drives over mine and bends it. But now we'll go ahead and back this skid steer on here. It's easier, and a lot of people would tend to perhaps drive a machine on facing forward. I think my preference is, and I think a best practice is actually to back a machine on, because it's generally much easier to get the weight distribution that is needed. Most of the weight of this skid steer is located about at those drive sprockets and back. So if you drive it on, you need to drive it much further forward. If you have some buckets or something on the front of the trailer, you won't be able to get the machine far enough forward. So backing it helps with the weight distribution. To properly secure this, you need to have 4 points of contact with chaining it down. Of course, you want to make sure your chains are rated for the right weight capacity on the machine that you're chaining down. So right here on this particular machine, we have a tie down on this corner right here. We'd go from this point, specifically designed for that, and maybe to this stake pocket, or ideally over to this D-ring right here. Put a chain binder on that, snug it down good. Again, same thing on the other side. And that would constitute 2 points of our 4-point tie down requirement. Then on the rear, you could take a single chain and thread it through this hole, over through on the other side, and then just bring the chain out and again, hook to the stake pocket as you deem best. But then if you could put a chain binder on just one side and tighten that down, and each side would be considered a point of tie down. So that would count as 2 other points of tie down, and you'd have your 4 tie down points. So just in quick synopsis, we've got good weight distribution, properly chained like that, it'd be properly changed down. If you turn this thing over, the trailer would stay with the skid steer and you wouldn't have any failure for load securement. And if you were ever checked out by law enforcement, everything would pass. That's what they would be looking for as far as that goes. Now we'll transition and we'll look at a trailer that has a piece of equipment on it that is improperly loaded, and I'll talk about why and what I mean by that. So here we have a machine. This was actually brought in by a customer this morning, and they were able to tow this safely. Everything worked out fine, so that's great. I have no problems with that. But there is a couple things that I would recommend as better practices or as best practices that this is a good example of how it could be done better. First of all, the center of gravity on the machine, a machine like this, again, this one, mini excavator like this will have a counterweight in the back. So the engine and the counterweight are in the back. I would estimate the center of gravity of this machine to be about here, especially with the boom stowed in the current position that it's in, somewhere in this range. And so if you compare that to the axles, there's not a lot of weight that's being transferred to the tongue. Most of the way the machine is either balancing on the axles or even maybe behind the axles. And in fact, when I help the customer unhook this trailer off their truck, I notice the tongue is very light. There's not much tongue weight as this sits. Hauling it locally at low speeds, it may not be a problem. If you were to tow this down the interstate at 70 miles an hour, you'd probably feel it not be very steady back there. You'd really want to have more weight on the tongue. The securement with a machine that has an attachment, so like a backhoe or an excavator, mini excavator, you're required to also have a point of attachment, 2 points of attachment for the machine's attachment. So you have 4 for the main body of the machine, just like we saw for the skid steer. And as this is chained and sitting here, it has that. We've got the 2 in the rear, we've got the 2 in the front. They go through their designated spot, everything's good there, but it really should have a chain going through the bucket yet, and either side then would count each 1 point of load securement there, so you'd have your 2 points on the bucket. And the final thing is that I'll mention here is the boom is facing forward, and this isn't a very tall load, but it is possible to encounter maybe some low-hanging wires, phone wires, hopefully not a power wire, but that's within the realm of possibility. Or on a rural road, you might find one of those low railroad bridges. And here locally in Winchester in Tennessee here, we have a couple of those that I've found to where this load won't fit underneath of it. So with the boom as it is, it's more prone to snag a wire and not pop it over, depending how it would hit. And also, if you were to hit a bridge with the boom facing forward, it has a tendency to jam and make a bad situation even worse. Whereas if the boom was facing to the rear, just with it facing to the rear, it's more likely to bounce a wire up over it so that it wouldn't catch in case you did encounter that. And if you hit a bridge, it would still wedge, but it wouldn't be quite as extreme of a jammed situation if you were to strike a solid object. Next here, I'll actually unchain this machine and we'll move it forward, and I'll kind of have it sitting there as I would recommend, or to demonstrate what I'm referring to. So there you can see we're able to move the center of gravity on the machine much further forward to be able to get good weight distribution, and we're able to stow the boom lower and also in a way that would not tend to catch or snag wires as much. So there's some pointers. I hope that's been helpful. If you're hauling equipment, a lot of things to think about, but like I said, hopefully that's been a help.